So you can see even and odd functions. Yes, you can just see even and odd functions. A function f of x is said to be even if you can see this f of minus x is equal to plus f of x. F of x means you know already it is a function. Trigonometric functions are there, exponential functions are there. Yes, sorry. Trigonometric functions are there, and exponential functions are there, algebraic functions are there. So this condition satisfies, then we say the function is even. Similarly, herein we are going to consider here as cos x, sec x, and x square as the even function. Next, we see a function f of x is said to be odd if f of minus x is equal to minus f of x. Yes, we can see when we consider this as odd function, students, when we take this condition that f of minus x means any function, if I substitute the value of x as minus x, then we can say this minus is outside the function. Then we say this such type of functions are nothing but odd functions. So we can see sine x, cosec x, and x cube. So I think one example I have taken here. Suppose if I take any function, I will take some algebraic function as x square, which is equal to, suppose if I put x as minus x, if I put minus x in this equation, then you can see it will be minus x the whole square. Then this minus x the whole square is nothing but again x square. Is it clear? So one example I have taken here, that is, suppose if I take this as minus 1, x is minus 1, that implies minus 1 square will be again 1 square, or it will be 1. Similarly, we have cos x. So cos minus x, if I take cos minus x, will be always plus cos x. So this is about the even function. Please remember, this is a even function, students. Okay. Next, I will go to the odd function. What will be odd? Simple example I have taken, x cube. If I put, yes, x is equal to minus 1, that implies minus 1 cube is the function. So this is going to transform in minus 1, means x cube is an odd function. Similarly, we are going to take this as sine x. If I put x is equal to minus x, that implies sine minus x will be equal to minus sine x. Therefore, we take this as the odd function. Please remember this, students, practice this again. I'm just repeated previous class, and then you can see, just for your understanding, I have just one to graph that is symmetric about y-axis. Yes, whatever the function which is symmetric about this y-axis will give you even function. Symmetric means what? Suppose this line, this curve is in this form, then this curve will be like this. So it will be a mirror image. Similarly, you can see this at this point LHS, and at this point RHS will be same, but only thing is in opposite direction. You can see this is in LHS and this will be in RHS direction. Therefore, this will be mirror image in this y-axis. So therefore, this function is known as even. Okay, just remember. Okay, similarly, if you go for odd functions, now you can see this is symmetric about origin. How it is symmetric? Yes, friends. Suppose if I draw this line in this form, yes, this opposite sign, opposite direction, you can see like this. Exactly, it will be opposite through the origin. Then this will going to travel if this curve comes till here. Similarly, you can see this curve will take turn and come to this direction. So it will be in opposite direction. Such functions are always odd functions. And please remember, very important formula, student. By heart this formula, practice this. Definitely you can remember. Suppose if you take any even function in the Fourier expansion, especially now, we're going to apply for Fourier's expansion. You can see only cos terms. You can see only cos terms in the interval minus c to c. C is any values, any constant. Suppose they may give any pi value is there, 2 pi is there. Yes, some constant they will give. Remember the formula for a naught. 2 upon c integration 0 to c f of x dx, and similarly an is equal to 2 upon c integration 0 to c f of x cos n pi x upon c dx. So this is also cos function, and a naught is also cos function. You may say how it is cos function, sir? Then I will tell you that if you take n is equal to 0, an if you take 0, you can see you will get a naught. That's simple. So therefore a naught and an are cos functions. Then you can see bn is equal to 0. Bn is sine. Therefore bn is always 0. Therefore we get the Fourier series. What is Fourier series you are going to get? Yes, you can see here, students. It is f of x is equal to a naught upon 2 plus summation n 1 to infinity an cos n pi x upon c. Please remember this formula, students. Otherwise take the screenshot or you can write down. Okay. Similarly, we'll go for the odd function, students. Yes, you can see odd function. Odd function for Fourier's expansion. You can see only sine terms are there. Cos terms are not there in this odd function, students. So from this interval will be from minus a to c. And then you can see here, students, a naught is equal to 0, an is equal to 0. Okay, then you can see only bn is there. Bn is equal to 2 upon c integration 0 to c f of x sine n pi x upon c dx. So if you substitute in the Fourier series, you can see we get the Fourier series as f of x is equal to summation n 1 to infinity bn sine n pi x upon c. So this is just I have revised for you once again, and then we will go to the example, students. Is it clear? Okay. Now this is our question. Obtain the Fourier series expansion of the function f of x is equal to x minus 2 pi in the interval 0 to x 2 pi pi to x till 2 pi, and hence deduce that pi upon 4 is equal to 1 minus 1 upon 3 plus 1 upon 5 and so on. So we'll just simplify this, friends. I just change the ink. Okay, just change the color. So this is what the question is given, friends. So already your have done already. So where is that line? Yes. Okay, you have solved. So your half of the work will reduce if you identify this is odd or even function. So first you identify odd or even function. So what I will do, I will take the function I will take the function f of minus. As I have told you, whenever x is there, you have to just substitute minus x. So this I will substitute minus. So I'm going to take, it is x minus 2 pi. Okay, so I'm going to take f of x is equal to x. In the form of x, I will just substitute x minus 2 pi, minus of x minus 2 pi. So this is equal to, actually you should get, this is minus x minus 2 pi. If you take the function, that is f of x is equal to x, if you take x, you have to substitute this value. Then this will be equal to, I will take minus inside, it will become minus into minus will become plus. So I'm going to take this as plus 2 pi minus x. So minus x, I have taken just minus inside this bracket. You can see this equation will be minus into minus will be plus 2 pi minus x. Then further you can simplify this. This will be equal to, it is exactly opposite of this value. Therefore, I can write this equation as minus f of x minus 2 pi. Is it clear, student? So like this, you are going to get this function. Therefore, you can see f of x is, see, you can see minus is outside, students. Is it odd or even? Please tell me. Yes, students. Yes, please unmute and tell me. Odd or even function? Yes, it is odd function, because if I substitute x is equal to minus x, minus is outside. You can see here, this is. So therefore the function is odd. So when you take odd function, please remember a naught is equal to an is equal to always 0. Please remember the function, student. Therefore, you are going to get this as bn is equal to, it is, you can write the formula, that is 2 upon c integration c 0 to c f of x sine n pi x upon c. Yes, therefore you will get the Fourier series like this fs, that is Fourier series as f of x is equal to summation n 1 to infinity, it is bn, okay, sine n pi x upon c. So you can see the interval, students. If I take this first value, that is the interval they have given here, therefore the interval they have given 0 to pi. Is it clear, friends? Suppose. So I will substitute c is equal to, I will get here pi value. So now in the interval, what will be then bn? If I solve bn, your work is over. So I will solve bn. Bn is equal to 2 upon c. I have calculated it as pi. So substitute this is pi, and then integration 0 to pi. You can see this, friends. F of x sine n pi x upon c. C is again pi, student. Therefore, this value is pi. So pi and pi will get cancelled. Therefore, I will just write here. It is sine n pi x. Sorry, this one c is equal to pi. Pi and pi will get cancelled. You can see I will get only sine nx. So okay, so this is what I'll get, because this is c is equal to pi z, pi and pi will get cancelled, therefore sine nx I will get. So this is what we get the bn, students. Okay, now substitute the value of f of x. So I will take again 2 upon pi outside. In the interval 0 to pi, yes friends, in the interval 0 to pi, you can see the function is x, sine n x. Okay, now further if we simplify, you can see a student which is equal to 2 upon pi. Yes, this is again u into v, students. You can see this is a product of two functions, integration of product of two functions. Okay, now simplify this, students. Again, see this is u, keep u as it is, that is x as it is, integration of sine nx. Yes, friend, what is integration of sine nx? It is minus cos nx upon n. So already we have solved and simplified all the values. Now I'm going to substitute the values one by one. So minus differentiation of x. What is differentiation of x is 1. Again, integration of minus cos nx upon n. Yes, that is 2 times integration of sine nx, that is v2. So you are going to get here minus sine nx upon n square. So like this you can write the values very easily. Next you can see why I cannot write the next term, because if I differentiate 1, I'm going to get this as 0. So we have to stop till here, students. Okay, this integration will be from 0 to pi. Okay, now substitute the value, students. This is equal to, now you can see, as you have to remember that sine, please remember this value, that is, I will write the formula here. Sine n pi is 0. Also remember sine 0 is also 0, means this term will be 0, students. Suppose if I take x is equal to pi, this full value will become 0. If I take x is equal to 0, this full term will become 0. So what we are left with? We are left with this value. So you can see I will substitute first pi value and then I will substitute 0, students. In this you can see minus is constant. I will take minus outside, and also I will take n is constant, that also I will take outside, students. So you can see here it will be minus 2 upon n pi. I have taken minus outside because I don't want minus in this term, because I'm going to substitute pi and 0 value. Similarly, n is constant, that is also not required, so I have taken it outside. So what is remaining here, students? Here only cos x cos and x is remain. Only x terms I have kept in the bracket because I have to substitute upper limit and lower limit. So this is equal to, students, it is minus 2 upon n pi. Now I'll substitute first pi value. So this is pi and this is cos n pi. You can see this is next, it will be minus. Is it clear? Minus, you can see I'm going to substitute x is equal to 0. So if I substitute x is equal to 0, you can see here we have x term, this will become 0. If this term will become 0, into cos and 0 will become 0. Okay, so this will be 0, students. Okay, further we can simplify this like this, students. This is equal to, now you can see here in the numerator we have pi and in the denominator we have pi value, so it will get cancelled. And as I already told you to please remember the formula, when it will be cos n pi, sin n pi, some values you have to always substitute. And here in this case you can see cos n pi is equal to minus 1 raised to n. So substitute the values, so it is 2, this term will be minus 1 raised to n, therefore I will write here minus 1 raised to n, minus 1 raised to n divided by what term is remaining next? N is remaining, students. So this is our Bn. Is it clear, students? If you have any doubt, please ask me. So n value we have calculated here, students. Bn value we have calculated. Okay, now substitute in the Fourier series. What is Fourier series is given for odd function? It is f of x is equal to, please remember the formula, summation n1 to infinity. Yes, it is Bn. Bn is what, students? This is our Bn. Substitute the values, that is minus 2 minus 1 raised to n upon n. Then we have sin nx. So this is our Fourier series. Please remember this, students. Now I have to deduce this equation. You can see they have given pi upon 4 is equal to 1 minus 1 upon 3 plus 1 upon 5. If you show this much, finish. So I think it is quite easy than previous examples. So I'll substitute such a value that it must be deduced to at least RHS I should get pi by 4. So I will substitute x is equal to, put x is equal to pi by 2. Let us see. So if I take x is equal to pi by 2, I have taken, this is an odd function, therefore f of x I have taken here x only. So you can see f of pi by 2 will become pi by 2. Therefore pi by 2 is equal to summation. Next you can see here constant, that is minus 2 is constant. I will remove it outside. So this will be minus 2 summation n1 to infinity minus 1 raised to n upon n sin n pi by 2. So x I have taken pi by 2. Okay, now you can see here, students, I will substitute one by one, that is n is equal to 1 only for sine terms, that is sine pi by 2. What is sine pi by 2? I think everybody knows it is 1. So if I take n is equal to 2, sine 2 pi will become 0. Please remember this. You can put it in the calculator. Yes, consider only the radian. Please remember, substitute radian. Sine pi by 2 will become 0. Continuously go on changing n value. N is equal to 2, you will get 0. N is equal to 3, you will get sine 3 pi by 2. You can calculate in the calculator. You will see, take it as radian. You can see this is minus 1. N is equal to 4. You can see it is 0. N is equal to 5. You can see it is sine 5 pi by 2, which is equal to 1. You can cross verify, students, please. N is equal to 6. If you take, you're going to get sine 6 pi by 2, which is again 0. So n is equal to 7. You can see this, students. Sine 7 pi by 2 is equal to minus 1. So like this, I'm going to substitute n is equal to 1, 2, 3, so on. So that implies, you can see here students, minus 2 I will take this side. So it will become minus pi by 4, which is equal to, I'll substitute n is equal to 1. So minus 1 raised to 1, this is 1. Okay, sine n is equal to 1, when sine is 1, n is equal to 1, sine pi by 2 will be 1. Okay, next plus. Yes, you can see when n is equal to 2, it is 0. So I will not take n is equal to 2. Directly I will go to the n is equal to 3 value. When I substitute n is equal to 3, minus 1 raised to 3 upon 3, and sine n pi by 2 is minus 1. So you can have already simplified. Similarly, next value n is equal to 4, you can see sine term is 0. So I will not write 0. Next, n is equal to 5, I will substitute here. So it will be minus 1 raised to 5 upon 5. Sine 5 pi by 2 is 1 plus 1. Similarly, 6 is 0. So I will not write 6. Next, I will take my directly 7. N is equal to 7, friends. Now you can see sine 7 pi by 2 is minus 1 and so on. So this will continue like this. So you can continue. So therefore, simplify this ones, minus pi upon 4 is equal to minus 1 raised to 1 will be minus 1 only. Okay. Here you can see minus 1 cube is minus, minus into minus will become plus. So it is plus 1 upon 3. Next, here you can see minus 1 raised to 5 into 1. So this is minus 1 upon 5. Similarly, minus 1 raised to 7 is minus 1. Minus 1 into minus 1 will become plus 1 upon 7 and so on. Further, you can see here students, I have to multiply here minus 1 on both the sides, because it is understood that this value is always pi upon 4 is positive. That is what I have to deduce here student. Please remember, pi by 4 I have to deduce. What, how you deduce, I don't know, but you should get here, that is LHS pi by 4. So this is equal to, multiply here, minus minus into minus will become plus, so it is 1, and plus will become minus, minus will become plus, and plus will become minus, and so on. So now we can see, compare this equation with this equation what we have reduced. Yes, it is pi by 4 is equal to 1 minus 1 upon 3 plus 1 upon 5. Yes, minus 1 upon 7. So this is how we have to deduce this equation, students. Is it clear, students? Still, if you have any doubt, please ask me. Yes? No doubt? Okay. So in this, because this is very, very important, at last example, some of your friends asked me to just repeat that. Shall I repeat that example, students? Yes? Previous example for the even function, shall I repeat it? Yes, please tell me. Shall I repeat? If you tell yes, I will repeat the example. Please type it in the chat box, students. Shall I repeat that example, previous example? Because as we have time, therefore in 15 minutes you can solve this example. Shall I repeat this, students? Please type it in the chat box. Yes, Priyanka, thank you. So, what was the last question? Yes. So how many times you repeat the examples of Fourier series, that will be helpful, students. Okay. Let me just make this dark a little bit. Dark. Okay. So this example was little bit changed. That is, they have asked you as sketch the graph. Okay. Sketch the graph of the function of the function f of x is equal to mod x, because this is an important example for your exam purpose, students. Please remember this, and for OBA also, and for your internal also for final exam. Please practice such examples, obtain its Fourier, yes, series. So it is quite easy than previous all examples, and please remember, it is definite, either even will come or odd will come, students. So deduce that at least you can try such examples which is quite easy. And as you remember, I always repeat the important things. Okay. Everything is not important. What is important? Definitely I will repeat it, and I will make you to practice the example, students. Now, okay, we'll start the example now. Okay, now I can see in the previous class also some of the students were absent. For them it will be more helpful, and who were present, for them it will become practice, and you will become perfect in the Fourier series. Okay, now always whenever the question is given, first you have to take the value, the function. Let f of x, I have to take this value as mod x. Okay, when you get this as mod x, students, please remember I'm going to draw the sketch the graph. Okay, so some of your friends were got confused how to sketch the graph, so I will show you. Yes, once again I will repeat this. So if I am not satisfied, definitely I will repeat the example. So this is x-axis and this is y-axis. Now I have to take, whenever this graph we are going to draw x-axis and y-axis, please remember y I am going to take the function f of x. The curve always, it is always denoted by y is equal to f of x. So how we are going to simplify this? I will show you. See, y is equal to, now this f of x is what, students? It is mod x. Please remember they have already given here f of x is equal to mod x. Okay, now I will substitute one by one. You can see I will substitute x is equal to 1. That implies y is 1. Am I right? Am I right, students? When I take x is equal to 1, y you will get 1. So we can see x is equal to 2. Then you can see y is equal to, I will get this as 2. I am going to substitute in this equation. Equation 1 I will keep this. So means that as x increases, yes, it is 1, 2, 3, 4, y also increases. Please remember. So I'm going to take this as 1, 2, and so on. Similarly, this also increases 1, 2, and so on. So this is y is equal to x. I will get till where it increases, friends. Yes, please remember till pi, because the interval they have given minus pi to pi. Therefore, it will be both are positive. X and y are positive. Therefore, please remember it will come in the first quadrant. Yes, it will come, the curve will come under first quadrant and the interval is pi. Okay, now similarly, what I will do? Similarly, I will choose again y is equal to mod x the value. Okay, so now I will choose, now I will substitute x is equal to minus 1. So please tell me, if x is minus 1, what is the y value? Please tell me, put it in the chat box, friends. What is the y value? Please unmute and tell me. Yes, if I take x is equal to minus 1, yes, correct. So y is also plus 1. If I take x is equal to minus 2, y is plus 2, student, because it is mod x. So any negative term if you put, you are going to get y as positive only. Means x is negative, yes, x is negative and y is positive, means the curve will come in the second quadrant, and therefore I will get the line in this form. So like this, you can see here y is equal to, I am getting as x minus x. Therefore, this interval will be here dot dot dot. It will come to minus pi. So the interval will be from minus pi to pi. You can see this. Yes, it is minus pi to pi, students. Now we will simplify this. Okay, this is how you are going to sketch the graph. Is it clear, students? Yes, very good. So I will start with our taking the function f of x is equal to mod x. Okay, now I have to obtain the Fourier series and deduce. Okay, now what I will do? As you remember, now you are perfect. Can you tell me this is even or odd function? Please unmute and tell me. Even or odd function? Yes. Now I will substitute here f of minus x. Is it clear? So if f of minus x is equal to, this will become mod of, I'm just replacing x by minus x in this equation 2 I will take. So minus x, if I substitute, f of minus x is equal to mod of minus x, students. Means what will be the x? Yes, if it is plus or minus, in this mod it will always be positive x. Please remember. So means what? What is this function, students? Is it even or odd? Yes, f of x is an even function. Yes, you are right. So it is a even function. Please remember this is a even function. So when even function is there, then you can see immediately bn is equal to 0. 50% of work is reduced. If you find the function is even or odd function, you can see bn is equal to 0, students. Means immediately you should write the Fourier series formula, that is f of x is equal to a naught upon 2, yes, plus, means bn will not be there, means sine functions will not be there. Please remember, only cosine functions remain will be there, that is a naught upon 2 plus summation n1 to infinity an cos n x. These functions will be there. Okay, now substitute one by one. You are perfect. Some of your friends have already solved very easily. So I'll repeat this again once again. A naught is equal to, please remember now, what is c here? Yes, the interval we have already taken, minus c to c. This is a constant, but c they have given minus pi to pi. So in this interval they have given, therefore indirectly c is equal to pi. So therefore a naught is equal to, please remember the formula, students, it is 2 upon c is pi. I have substituted, now c is equal to pi. Okay, integration from 0 to pi f of x dx runs. Now substitute in the values, yes, so this is equal to 2 upon pi as it is, integration 0 to pi. What is f of x, students? We have taken f of x is equal to mod of x. So mod of x is a positive value, therefore in integration I will consider only the term x. Is it clear, students? It is actually mod x, but for integration, for simplification, I have taken instead of mod x as x only. So it is plus or minus. Directly you can see it as a positive value. So this is equal to, students, I am going to get this as pi upon, sorry, 2 upon pi. So integration of x will become x square upon 2 from the lower limit and upper limit as 0 to pi. So you can see, students, that 2 is constant. I will remove 2. So what is remaining now? Yes, it is 1 upon pi. Now I have to substitute x is equal to pi. So this is going to become pi square minus 0. So you can see again here pi square is there, 1 pi will get cancelled automatically. Therefore a naught is equal to, it is pi. This is very simple. Now an you are going to calculate. Please remember the formula again. What is a naught formula? We have 2 upon c. C is nothing but pi value. Integration from 0 to pi. This is f of x cos n x dx. Please remember c is equal to pi. So again here pi will get cancelled. Therefore I have directly written cos nx. Okay. So this is equal to, take 2 upon pi outside. Okay. So next integration f of x. I think you remember what is the function f of x is x value, that is mod x. But again we are going to consider only the positive value. Therefore I have taken this as x cos nx dx. Okay. Now you can see here, students, this is again integration of product of two integration functions. So what will be the integration? I will keep x as it is. Integration of cos nx. As you remember the formula, student, that is integration of u into v. U v1 minus u dash v2. Please remember this formula. Yes. So integration of cos nx will become here sin nx upon n. What is differentiation? Next differentiation of this x is 1. Next again integration of sine nx. It is going to become, yes, minus cos nx upon n square. Again next term will be what, students? Next term will be 0, because again 1 differentiation of 1 is constant term, 1 is 0. So next all terms will become 0. Therefore we'll stop integration till here. That is by using the Bernoulli's rule. Please go through the last lecture. You can see Bernoulli's rule I have explained. So now we'll substitute one by one. Now you can see here, students. Again, yes, please remember whenever you get the value sine n pi, Please remember sine n pi is 0. Again, sine 0 is also 0. Means in this term, if I substitute pi value, you will get it here 0. And if I substitute x is equal to 0, this term will become 0 only, students. Now you can see the term, this term. So you can see minus into minus will become plus. N square is constant. I will remove n square outside. So this is n square. I have removed outside. Okay. Now you can see only this term is remaining. Minus into minus will become plus, so therefore cos nx is only the term remaining, students. Is it clear? Now just simplify this. This is equal to 2 upon pi u n square. N square I have taken outside because it is a constant term. Therefore now I am going to substitute here cos x is equal to pi. Therefore this is n pi minus cos 0. Cos 0 I will directly substitute here, students. It is 1. Therefore cos 0 is equal to 1. And please remember, students, what is cos n pi? Yes, in the last previous class I have told you it is minus 1 raised to n. Substitute the values directly, students. So this is equal to 2 upon pi n square. This is minus 1 raised to n minus 1. So this is what the value we are going to get here, an. So you know a naught and you know an. Substitute in the formula. Yes, because bn is 0. Please remember this is a even function. Therefore I will get the Fourier series. Fourier series is given by. Now I'll substitute both the values. So you can see f of x is equal to a naught upon 2. What is a naught, student? It is pi. So it is pi upon 2 plus summation n 1 to infinity an. What is an? Substitute the value. It is 2 upon pi n square, and here the minus 1 raised to n minus 1. And next cos n pi x upon c. C is again pi. Pi will get cancelled. Therefore cos nx. Directly will write the value. Okay. Now you can see here, student, this is our Fourier series. Now I have to deduce this upon 1 upon 1 square plus 1 upon 3 square till so on pi square upon 8. So LHS I will keep pi square upon 8 fixed. Then I have to deduce this equation. Therefore I have to substitute that. I have to put such a value that I should deduce that equation. So therefore I will take x is equal to 0. So this equation will become, so when I take x is equal to 0, so because f of x is mod x, and which is x is 0 means I will get this as 0 only, because f of x is equal to mod x. F of 0 will become 0 only, students. So therefore directly I will take this as 0 is equal to pi upon 2 plus, again in this terms I will remove constant. 2 is constant, pi is constant, so I will remove outside 2 upon pi summation n 1 to infinity. You can see I will get here minus 1 raised to n minus 1 upon n square. Please remember cos 0 is 1. So this value, this term will become 1. So I will not write that term in this equation. Please remember I have taken x is equal to 0. Okay, is it clear, students? Okay, fine. Next what I will do, I will bring this minus 2 upon pi plus pi upon 2 this side. It is going to become minus pi upon 2 is equal to 2 upon pi summation n 1 to infinity minus 1 raised to n. Yes, we will get this value. So I don't want this minus, so I will multiply here minus on both the sides, and this term 2 upon pi I will bring it on this side. Pi will go up, denominator will jump to numerator, and this 2 will come to the denominator. Therefore you can see, and I will multiply minus 1 on both the side, because I want this plus. Why I want this plus, students? Because in the question they have n plus pi square upon 8. So for plus pi square upon 8 I am going to multiply here minus 1. Therefore you can see this is pi square upon 4. 2 into 2 will become 4. This is equal to minus summation n 1 to infinity minus 1 raised to n minus 1 upon n square. Please remember this. Now you can see minus I will take inside. If I take minus inside, what will happen to this equation, students? I will keep this term as it is. Summation n 1 to infinity I will keep as it is. Here if I take minus, you can see this plus will become minus, and this minus is going to become plus. So I can write like this: 1 minus minus 1 raised to n divided by n square as it is. Why this has happened? Because I have taken this minus inside this bracket. Therefore this equation will become minus into plus will become minus. So I have written here minus, and here this is minus 1. Minus into minus will become plus 1. Okay, now further if you want to calculate this, students, now you can see this equation, that is my 1 minus of minus 1 raised to n, this is equal to 0. Why this is equal to 0? Yes, friends, you can see here, this will become 0 if n is even. Please remember, if n is even, so you can take n is equal to 2, 4, 6. You can see it is always even. If I take this is equal to 2, if n is odd, yes, n is odd, because n is equal to 1, 3, 4, sorry, 5 and so on. Why this is happening, students? You can see here one example I will show you this side. If I take n is equal to 2, this will be 1 minus 1 raised to 2. You can see this will become plus, minus 1 will become plus, therefore minus 1 into 1 will become minus 1. 1 minus 1 will become 0. Suppose if I take n is equal to 1, so what will be this value? 1 minus 1 raised to 1. If I have taken here n is equal to 1, that implies 1 minus of minus 1, minus minus will become plus, 1 plus 1 will become 2. Similarly, n is equal to 3, n is equal to 5. For odd values it will be 2, and for even values you can see it is always 0. So therefore I want only odd terms, because I want this 2 value to deduce this. So therefore I will continue this equation. So it is pi square upon 4 is equal to, so you can see here, summation n 1 to infinity, because this is an odd value, therefore this term I am going to take here 2, 2 upon n square if n is odd. Please remember, n is odd here, students. Okay, now you can simplify this. 2 I will take outside. Summation n 1 to infinity, what is remaining? 1 upon n square. Because n is an odd value, therefore I'm going to take here n is equal to 1, 3, 5 and so on. So 2 I will bring this side. You can see it is pi square upon 8. 4 into 2 will become 8. Therefore this is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, because n is odd, student. Please remember, n is odd, and so on. Now I can compare this equation and look here. Yes, we have deduced, what is that? 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to pi square upon 8, student. So like this you have to deduce this equation. That is what we have proved. Yes, thank you, friends. Yes, if you have any doubt, please ask me. Yes, friends.